This video is going to cover Unit 3, which is all of the calculations, so the mole quantities, converting moles to mass, to molecules, and then empirical formulas, molecular formulas, percent composition, things like that. Limiting reactant, those types of concepts. So the first thing is just molar mass. So anytime you see these stars that I've circled right here, that means that it's actually on the review module. So as you're working through that, if you want to, watch this video first, that might help you answer some of them. This video doesn't contain all of the practice problems, but it does contain some of them, so it can get you kind of started on those types of calculations. So the first thing that we're looking at is molar mass, and I have a periodic table here to kind of help us answer these. So we get our molar mass by looking at the average atomic mass. So for example, carbon is the first one, so I'm just going to look at the mass there, and I can see that the average atomic mass is 12.01 grams. For B, calcium chloride, I would just look at my periodic table. Calcium is right here, so it's 40.08, and then chlorine is right here, 35.45. So I have 1 calcium, and then I have 2 chlorine, so I have to multiply chlorine twice together. So when I add all of that up, you end up with 110.98 grams. For this one, magnesium nitrate, I'll start by just writing everything out. So I know I have 1 magnesium. For nitrogen, this 2 applies to everything inside the parentheses. So we have 2, and then oxygen, we have 2 times 3, so 6. So when I come and look at my mass, I can find magnesium is here. Nitrogen and oxygen are right here. So I can add that. Magnesium is 24.3. Yeah. And then nitrogen was 14.01 and oxygen was just 16. I'm sorry about to write that backwards. So oxygen was just 16. So if I multiply those out and add them all up together, I still just have 1 magnesium, so that's just 24.3. Nitrogen becomes 28.02, and then oxygen becomes 96. So now when I add everything up together, you get 148.3 grams. Okay. The next thing is just mole calculations. So remember, when we're doing mole calculations, we're always looking at how many things are in 1 mole. If I'm given something like grams, right, which is the mass, then I'm going to use the periodic table and the molar mass to help me convert back and forth. If I'm given something like atoms or particles, okay, any of those things we talk about, then we're going to use 6.02 times 10 to the 23rd. That's Avogadro's number. So remember, we can go back and forth however we want to. Just make sure you remember we're always using the 1 mole here. So it's how many grams are in 1 mole, and then how many atoms are in 1 mole. So let's look at our first calculation. And so here are the stars. So that's telling you this one is on the homework module. So we always start with what we're given. So 7.3 moles of sulfur. Okay, and then I'll just set up my train tracks. So remember, if I have moles on the top, I know I want to put mole on the bottom. Remember, it's always 1 mole. Okay, and then we're going to atoms. So if I look at my map here, I just want to stay on this side of the map because I'm only talking about atoms. So I know that I'm using this number right here, 6.02 times 10 to the 23rd. Okay. So when I come down here, I'm going to put 6.02 times 10 to the 23rd atoms. And then now when I type that in my calculator, remember everything across, we always multiply. So we end up with 4.39 times 10 to the 24th. Okay, and if I wanted to do sig figs, this has 2 significant figures. So I would actually change that to 4.4. Okay, and then this is atoms, because it asks me how many atoms. Okay, for this one, it says, I'm always, again, starting with what I'm given. So the only number I'm told here is 14.0 grams of H2O. Okay, so I always just start with what I'm given. And then it's asking me about moles. So if I look up at my map, okay, it's only talking about this side right here. Right, I'm going from grams to moles. So that means I have to use my molar mass. So I'm going to come down here. And remember, we calculate our molar mass by adding up everything we have. So we have 2 hydrogens and then 1 oxygen. And I just got those numbers from the periodic table right here. So 2 hydrogens and then 1 oxygen. When I add all of that up, it's 18.02 grams. So I'm going to put that on the bottom because I have grams on the top. I need grams on the bottom. And remember, it's always equal to 1 mole because that's what our map says, 1 mole. And I'm looking for moles, so now I can stop here. And then remember, anytime we have something on the bottom, we're just going to divide. So I'll do 14.8 divided by 18.02, and my answer is 0.822 moles of H2O. Okay, for this one, we're going to actually go 3 steps. So we'll start with what we're given, 4.5 times 10 to the 12th atoms of oxygen. Remember, oxygen is diatomic. So we write that like O2. That's part of the Brinkloff. So we'll put our train tracks, and then let's go up to our map. So it says we're starting here. We have atoms. So our first step to moles, we're going to use our Avogadro's number, 6.02. So we'll say 6.02 times 10 to the 23rd atoms. And again, that's always 1 mole. Okay, always 1 mole. So now we're at mole. Now we're going to go this way to our grams, and we're going to use our molar mass. So if my molar mass of oxygen of O2, there's 2 oxygens, so that's 16 times 2, 32 grams. So if I have moles on the top, I have to put moles on the bottom. And then I can just say 32 grams of O2. So now I'm ready for my answer. So everything on top, we're going to multiply, and then everything on the bottom, we're going to divide. The main thing to remember with this one is we put our parentheses around our numbers there. So I'm going to do 4.5 times 10 to the 12th times 1 times 32, and I want to divide by 6.02 times 10 to the 23rd. So my final answer is 2.39 times 10 to the minus 10. And this is grams. All right, for percent composition, this is where we're just trying to find how the piece of each part. So it's kind of like your percent on a test grade. You take how many questions you got right out of the total. So we want to find how much of each thing we actually have, and then we'll get a total. So I have 1 magnesium, right? There's a little invisible 1 down there. I have 2 nitrogens, because remember the 2 applies to everything. So 2 nitrogens, and I'm going to have 6 oxygens, because 2 times 3 is 6. So I can use my periodic table to get my masses. And then when I add everything up, I end up with 148.31 grams. So this is my total. So if I want to know the percent of magnesium, I can just take that percent and divide by the total. Same thing here. Divide by the total. And then same thing for my oxygen, divide by the total. So you can think of it kind of like, 3 different people. These are their different parts, and then divide by the total to get the percent. You will have to multiply by 100 at the end because you'll get a little decimal. So you'll have to move your decimal place a couple of places over, 2 places over. And I suggest you actually type these into your calculator as well. So if you want to pause it and type it in to see if you're getting the same answer that I am. Especially because you're having to move your decimal so you can see what it actually looks like on your calculator. Okay, so this is my final answer, is all of this here. Because I asked what was the percent composition of the whole thing. On the test, I may ask you, what's the percent composition of nitrogen? You would still have to solve the whole question, but you would just tell me 18.9%. Because I just asked for nitrogen. But you can't solve for just nitrogen without solving for the whole thing. All right, here we have just a balancing equation. So remember, you can go through and we'll just write everything out and then count what we have. So in this case, I have several polyatomics. So I have a sulfate, and I also have a hydroxide. And because you can see there's a sulfate here, SO4, and there's a sulfate here, SO4, I can actually count that thing as a whole instead of breaking apart the sulfurs and the oxygens and counting them all separate. Same thing with the hydroxide. Because it's an OH on both sides, I can count it like an OH. And then I like to draw a line down the middle so I can keep everything separate. And I'm not accidentally counting things on the wrong side. So aluminum, I'm just going to look at my little number, 2, SO4, little number, 3, magnesium, remember invisible, 1, and then OH, there's 2. On the other side, aluminum, I have invisible 1. Sulfate, I see the SO4, but notice how on the other side with that little 3, right, I had the parentheses around it. That was telling me how many sulfates I have. So here, this is just like if I had parentheses and then I had an invisible 1. I just have 1 sulfate there, not 4, because the 4 is actually part of sulfate. It's not SO, 4 SOs, it's SO1, SO4. Magnesium, again, invisible 1, and then hydroxide, here's my 3. So remember, I always save my hydrogens and oxygens for last, so we can look at the other things and see if we can get some stuff to start working out. So aluminum, I have 2 here. So if I want to turn this into 2, let me change my color here to something different. I can multiply by 2, and that means that 2 has to go in the lines. So whatever we multiply by is what goes on the blank. So now that gives me 2, and that matches. That also is going to mean that I have 2 times 3, a total of 6 OHs. Okay, so I want to go ahead and fix that. So now I'm just going to work my way down. SO4, I have 3 of them here, and I need to make 3 of them on the other side. So I'm going to say times 3. Remember, whatever we multiply by, that goes in the blank. So that gives me 3. But that also gives me 3 magnesiums. So I'm changing my magnesium to 3. Okay. And as I work my way down, that means on this side I have to multiply by 3. Remember, anytime you multiply by something, that has to go on the box, on the line. So now I have 3 magnesiums. But again, this 3 applies to OH also. So it's like saying 3 pairs, 3 2s. So that's going to make 6 OHs. So now I can just kind of double check. Let me clean up some of this junk around there. So I have 2, 2, 3, 3, 3, 3, 6, 6. Everything matches up, and remember there's just an invisible 1 in that first line there. All right, this is starting with stoichiometry. Remember where we're going to use our mole ratio. So we still have grams to 1 mole, okay, and grams to 1 mole. But in the middle here, we have our ratio. So if I want to convert between compounds, I have to use my ratio. And remember, your ratio is just your big numbers in front, your coefficients, and that's telling you how many you're making in your recipe. So here we're given 2 different things. So what do we always do with our givens? We just write them down. So I'm just going to write down my 2 givens. Okay, and then I think in the homework problem, it is asking for hydrogen, so we'll solve for hydrogen. And I can kind of double check that as we're setting this up. But I can make my train tracks. And now we're here. So we're going from grams to moles. So I know I do that by using my periodic table. So I can get my molar mass of zinc, which is right here, 65.38. And that's grams, and that's always equal to 1 mole. Okay, now I can use my mole ratio, and I can say in my equation, I have 1 mole of zinc for every 1 mole of hydrogen. Now I I'm here. So I just want to go back to grams. So 1 mole of H2, and I can look at my periodic table. Hydrogen is 1.08, but I have 2 of them, so that makes 2. And I just okay, yes, we're looking for hydrogen. So on the homework module, it's going to ask you for the theoretical yield of hydrogen in one problem, in the next problem. So I have 2.02 grams of H2. So now I can go through, remember everything on the top, we're multiplying, and then we divide by everything on the bottom. I get 0.772 grams of H2 for that one. So now I'm going to work the second reactant. So I have to find my molar mass of HCl, so I can look at my periodic table. And when I add up hydrogen and chlorine, we get 36.46 grams. And that's 1 mole. Now I can use my mole ratio. In this case, I have 2 moles of HCl for every 1 mole of hydrogen. And then the last part is the same. I'm just going from moles to grams. So multiply everything on the top, divide by everything on the bottom, and you get 0.485 grams H2. So in this case, remember the limiting reactant is the one that is limiting, right, the reactions, the one that get used up first. It's the one that controls how much you can make, and we can figure that out because it's always the one that makes the smallest amount. So I know my limiting reactant is HCl. And then when it asks me what my theoretical yield is, you've already calculated that. You did that in order to find the limiting reactant. So your theoretical yield is just 0.485 grams. The last problem for this unit is just an ideal gas law. So remember, anytime we're talking about gases, we only have 2 formulas. And if we mention moles, we know we want to use PV and RT because the N is moles. So here I can just plug in my information and calculate my missing variable. So it does tell me a pressure, 1.8. It tells me a volume of 1.7. It tells me moles. Remember, R you will get from the reference sheet is 0.0821, and then I'm solving for temperature. So if I want to get temperature by itself, I need to divide by those, but if I do it to one side, I have to also divide on the other. So then in my calculator, I'll just type out 1.8 times 1.7 divided by 4 divided by 0.0821. I get 9.32, And then remember, temperature is always in Kelvin. And that is the last calculation.